grade 5 scholarship exam, then O-level exam, they have reduced the content of the syllabus, but A-level they have not informed yet. But anyway, it will not be applicable to your batch, but it depends on the situation in within next few years. But O level, they have this time O level batch, they have reduced the content, like actually they have removed about 50%, like electronic lesson completely removed, electrochemistry 50% they have removed. So already the exam is postponed until May. Oral exam, A level exam postponed until February, as I remember. Then your batch, anyway, it's not confirmed yet, but A level also there can be a change the exam date, especially 2022 batch. So not that will not be in August, but your batch they are informed later. But anyway, you have to get prepared for 2023 August, right? So you have to plan the syllabus to complete the syllabus. And general chemistry, the first three lessons, I hope most of you have completed now, right? Until at least up until bonding lesson, because don't ever think like the exam get postponed, content will be reduced, so you have to get prepared for everything, and then by 2023 August. Now we have almost completed three papers or three tutorials, including past papers and some model questions. Not all the subjects are like actually mostly science they have reduced the content. Other subject, max and the other main subject also, they have reduced the content of the syllabus. Yeah. Not by 50% from all the subject, but yeah, from each chapter the hardest part they have removed, but the standard of the paper they will not change. Now I'll share the screen again. Let's see the answers for this. Right. First one, when a mixture of nitrogen monoxide and nitrogen dioxide is cooled to -20, they react to form dinitrogen tetroxide, right? Trioxide. So you have to draw the dot and cross diagram of N2O3. Okay. Now this one actually you cannot post the answer to the chat, but if you want, I can you can draw on my screen. You can annotate on my screen. If I don't know whether you are familiar, like it's whether it's comfortable with the mouse or what. If you have a writing pad or drawing pad, then you can do it on my screen. You can write the answer, or else you can take a the screenshot, or you can share to this you can share whatever you can, but anyway I'll write the answer, then you can check me, because if I can see you answer, then I can correct the mistake anyway. So N2O3, mostly what happened in the A level paper, they give the structure or the skeleton, right? The skeleton is given, but here I have not given the skeleton, because N2O3 you can arrange in different forms. So the skeleton is given in the A level paper, don't worry, but here I'll draw the skeleton for you. N2O3, this is how the atoms are arranged: oxygen, then nitrogen, then again oxygen, then again nitrogen, and then again oxygen. So this skeleton will be given in the A level paper, don't worry about that. So there are 2 nitrogen and 3 oxygen. So when you draw the dot and cross diagram, you can use dot for this terminal oxygen, then cross for nitrogen, cross for nitrogen, then again dot for oxygen, cross for nitrogen, and dot for oxygen, like that. So dot for oxygen and cross for nitrogen, then it will match. Or else you can use cross for oxygen and dot for nitrogen. Remember, nitrogen can form 3 bonds. So what is the most stable one will be, if you can draw. First I'll draw the skeleton here like this. If you terminal oxygen form double bond, otherwise the terminal oxygen will carry minus charge. Then this around this oxygen, anyway there are 2 bonds. So then each oxygen there are 2 bonds. So then that is satisfied, no formal charge on oxygen. So then you can draw this. So you can have a pair of cross here, and again pairs of dots here, 2 pairs of dots, and again pair of cross and 2 pairs of dots. Then you have to erase, because this one you have to erase. You have to put pair of dot and cross for to replace the double bond. To replace the single bond, you have to put here dot and a cross, and to replace here the single bond, you have to put dot and cross, and to replace the double bond here you have to put 2 pairs dot and cross, dot and cross. So this is how you get it. If you want to use a different color for this bonding pairs, so dot cross dot cross. And this one you but in the exam no need to use two different colors, just to distinguish the bonding pairs and lone pairs I'll do like this. Please raise the hand those who got this answer. N2O3. How many of you got this correctly? Right. Good. Okay, good. Then but now mostly they ask Lewis structures also and resonance structures rather than dot and cross diagram, but anyway there's a chance of asking. Yeah. Then next one, part B. The oxidation state of nitrogen is different in each of these three compounds. That means NO, NO2 and NO3, the oxidation numbers of nitrogen will not be same. Calculate the oxidation state of the nitrogen in NO and NO2 respectively. So yes, can you post the answer to the chat? NO, what is the oxidation number of nitrogen? NO, nitric oxide. Nitric oxide is, that is plus 2. Nitric oxide is plus 2. You can post the answer to the chat. Nitrogen dioxide, NO2, it is plus 4. Plus 4. Okay, Ran Suruni, correct. Good. Next one, part 2. Part 2, dinitrogen trioxide, that means N2O3. They have given, there are two resonance structures for N2O3. Sorry, NO2 minus, nitrite ion. There are two resonance structures. So one is given, you have to draw the other one. I'll erase this part. Part 2. Draw the other resonance structure. So how to draw the other resonance structure? Look at the screen. I can shift the lone pair from here to convert this into a double bond, and this one. So this can be converted double bond. This can be converted single bond. Right? This right. So instead of making the double bond from this side, you can make from this side to get the other one. And this side it becomes single bond. So you can draw nitrogen. You can have the double bond this side. Then no formal charge on oxygen. This side you can have single bond. Then you get minus. So then there will be a lone pair on this. When there's a minus charge on oxygen, there are 3 lone pairs. So this is the other resonance structure. Usually in the exam you have to put double-headed arrows if they are resonance structures. Please raise the hand those who got this answer. Right, good, very good. Then part 3. In aqueous solution, nitrite ion, highlight here nitrite ion, can be oxidized to nitrate. Write the ion electron equation for this. That means ionic half reaction. NO2 minus. So it become NO3 minus. Nitrite become nitrate. Nitrite become nitrate. Nitrite ion become nitrate. NO3 minus. So nitrite ion plus 3 and nitrate plus 5. Plus 5. So then oxidation number has increased from plus 3 to plus 5. That means what? 2 electrons are given out. And then in this side you can put 2 electrons. 2 electrons are given out. So it has got oxidized because nitrite is unstable. Example HNO2 nitrous oxide is Nitrous become nitric acid, HNO3, nitrous to nitric, because NO2 minus is unstable. So that is the ion electron equation. What I didn't get, Chaniti, what can't we arrange it to get nitrogen get minus? In which one you are talking about? Which part? Oxidation number of previous one. Who has posted this? Chaniti. In second one. No. The thing is this, yes. You cannot draw the resonance structure. So in the resonance structure, negative formal charge appear, Chaniti, on the most electronegative atom. That's why. Because nitrogen is more electronegative. Yeah, if you have any question, you can ask. If you have any doubt, you should ask. Yes, good that you asked that. So why we put minus charge on oxygen here? Because when you draw the resonance structures, negative formal charge should appear on the most electronegative atom, right? Oxygen is more electronegative than nitrogen. That's why. But if you want, you can draw, then it will be highly unstable. So I hope you got it. Then let's say we cannot put the formal charge minus charge on nitrogen. Nitrogen is less electronegative than oxygen. So I'll erase this. Then next one, part B. Part B, when alpha particles pass through, okay, you have done, I think, alpha, beta, gamma. You might have learned, right? Alpha, beta, gamma radiations. So out of this, alpha particle source. So alpha particle source. When alpha particles are passed through through an electric field, which letter diagram shows the path taken by them? Actually, out of this XYZ, why go straight? Why go straight without any deviation? So which one represent alpha particle out of XYZ? Yes, can you post the answer to the chat? Okay, Ransiluni correct, Seshan correct. What about Chaniti correct, Seshan correct, Ransiluni correct. What about Dinethmi? Dinethmi, what is the answer you got? Out of XYZ, which one represent alpha particle out of XYZ? Alpha particles are what charge? Okay, no problem. Dinethmi, now alpha particles are positively charged. Alpha particles, you have learned alpha particles, right? For your theory, alpha particles are positively charged, so it's same as helium. Beta particles negative, gamma neutral. So out of the three these three, the alpha particles positively charged, beta particles negatively charged, gamma neutral, uncharged. So here alpha particles get attracted towards the since it is get attracted towards the negative electric field, this X has to be positive. X should be positively charged particle, so it can't be beta or gamma. Therefore alpha particles are represented by letter X. Answer is X here. Very good, all of you are correct. Those who have posted the answer to the chat. Very good. The next one, name the other particles and the radiations emitted by radioactive source. Other than alpha particles, radioactive source can emit beta particles. So you can write it within bracket beta and gamma. Gamma, right? Okay. So a radioactive source can emit these three, alpha, beta and gamma. Actually out of these three, the highest penetrating power, that's what they ask next. Okay, shall I erase this and let's move to the next one. Out of these three, alpha, beta, gamma, ascending order of the penetrating power. Highlight the word penetrating power. Highlight the word penetrating power. Which one has the highest penetrating power? Yes, can you quickly post the answer to the chat? Yes, which one has the highest penetrating power? Ascending order, that means lowest penetrating power to highest penetrating power. Alpha has the lowest penetrating power, then beta, and then gamma. alpha has the lowest, huh? Gamma has the highest. You can, if you want to write in words, huh? I put the symbols alpha, beta, gamma. Good. Alpha has the lowest. Gamma can pass even through concrete slab. Huh? Alpha particles you can stop from a cardboard. Then ascend in order of the ionization power. 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 That means ionization power highest actually alpha, lowest gamma. Gamma uncharged. Gamma has the lowest ionization power. Alpha has the highest ionization power. Then in the middle you get beta. Okay, very good. Chaniti correct. Dinatmi correct. Good. Then next one, descend in order of velocity. That means velocity from highest to lowest. Descending means highest to lowest. Descend in order of velocity. Velocity from lowest to highest. Sorry, descending means highest to lowest. Highest to lowest. Highest to lowest. Be careful ascending and descending. Descending means velocity from highest to lowest. Velocity highest is what? Gamma. Gamma velocity highest. Then beta. Lowest velocity alpha. Lowest velocity will be alpha. Alpha lowest velocity. Remember gamma radiations. Gamma is considered as a, if you want to write the other difference, beta and gamma particles. Here beta and gamma particles, but alpha and beta particles. So that means there's a mass, but beta is considered as electron, alpha is considered as helium. Gamma chargeless and it's no mass, right? No mass, no charge. Please write it separately if you want. Gamma, no mass, no charge. Therefore, gamma is not considered as a particle. Gamma is a radiation. EMR, electromagnetic radiation. Gamma is electromagnetic radiation. Is that clear? Okay. Then next one. Question number 3. Shall I raise this? Anyone look up it? Please raise the hand. Those who got all 3 correct. ABC. Right. Good. Very good. Did you all start schools online at least? No, not yet, right? You didn't. Please raise the hand. Those who are hoping. Those who are hoping to join some other school for A-level. Anyone is hoping to join some other school like 2 of you. The others are hoping to stay in the same school. Anyone of you have started A-level your batch the school, any classes? Not yet. So I think now these days most of the online applications of most of the schools, and I think first they are planned to this time all to complete to do the exam first, and then after that you will they will consider about your batch. But anyway, there's a usually by May, June they start the schools, right? A-level batch, right? After December O-level, then March they release the results, and then but you did the exam in March. That's the problem. March they release the O-level results, and then by May they start A-level. Now it's not May, June, July, August, September, October, November, like about nearly 5 months, nearly 5-6 months. So that's then they will have to extend that in the future for your exam also. They will have to postpone in that way, in that contest, right? Okay. Question number 3, based on this table. Okay, you can see the full question now. They have given discrete covalent molecule, covalent network, ionic lattice and metallic lattice. Yes, the first one in the table. Which one match? You can put number 1, 2, 3. I will put here number 1, 2, 3, 4. Number 1, what should match out of these 4 substances given? Number 1, they have given do not conduct electricity and have high melting point. High melting point and but does not conduct electricity. So metallic lattice conduct. What is the most suitable one? Covalent molecule, no, low melting point. No? This one has low. I put low MP. I'll write here low MP. This one has low MP, low melting point. Covalent molecule. Discrete means like carbon dioxide, sulfur dioxide, like that. Low melting point. High melting point. Ionic lattice has high melting point, and covalent network has high melting point. Metallic also, it depends on the metal. High melting point possible, so some metals. So compare this one. What matters here? Conduct electricity. The both 1 and 2 conduct electricity. This one conduct electricity. This one does not conduct electricity. Conduct electricity. Otherwise, both high melting point common. High melting point common to both. Then you can filter that. High melting point, high melting point. But this one do not conduct, this one does not, this one conduct electricity. Then you can select out of these which one is metallic, because metallic conduct electricity, right? Conduct electricity when liquid, oh, but not when solid. Not when solid. That's very, very important. Conduct electricity in liquid form but not in solid form. Then definitely, then you can, this is definite, you can directly select this one. Some questions structured essay, so even essay type questions, so you cannot answer the part 1 the answer without reading the other parts. So this is also something similar to that. You cannot 100% accurately, you cannot guess by reading only the first one. The second and third also you read to get an idea, to have to get the answer for the first one. Yes. Number 1, what should be that? Number 1 and 2 now you can figure out. This should be definitely ionic, right? Number 2 should be definitely ionic lattice, because solid doesn't conduct, solid ionic compound doesn't conduct, liquid form it conducts. So therefore number 2 should be ionic lattice. Ionic lattice. Then number 1, what? So then ionic, I'll erase here ionic lattice. Ionic lattice done. Then what is remaining? Covalent network and metallic lattice. High melting point. High melting point, covalent network and metallic lattice. So can we write metallic lattice here? Can't. Why? Metallic lattice, conduct electricity. Then what is remaining? Covalent network. Covalent network. So part first blank, covalent network. That means like covalent lattice. Covalent network means covalent lattice. Then it's like graphite diamond also possible. Graphite diamond possible. Covalent network. Number 3, what? Conduct electricity when solid and have wide range of melting point. Conduct electricity when solid. It doesn't mean the liquid form also it can conduct electricity, right? They are not given only solid form. Solid also conduct electricity. Then it can't be definitely ionic. Ionic not possible. Covalent network also not possible. Then it should be what? Metallic. 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 Metallic lattice. Then number 4, do not conduct electricity and have low melting point. Do not conduct electricity and have low melting point. That is, what is the remaining one? Discrete covalent molecule. Discrete covalent molecule. Yeah. Okay, some of you have done it perfectly. Correct. Very good. Ransiloni, Dinatmi, correct. Chaniti, correct. Very good. So this is how you get from lattices and bonding lesson the questions. Sometimes in the A-level paper, structured set of questions, they can ask like this. They could ask like this. Then next one. I'll erase this. Part B. This is carbonate ion. What is carbonate ion? CO3 2 minus. What is carbonate ion? CO3 2 minus. CO3 2 minus will be the carbonate ion. So you asked to draw similar diagrams to show the other resonance structures. Actually, carbonate ion, there are 3 resonance structures. So the skeleton is given here. Actually, one is missing here. Wait, I'll lone pairs missing here. So I'll put the lone pairs here. Lone pairs missing. I'll put the lone pairs. Please add lone pairs, otherwise that's a problem. That's a printing mistake. So here we had put 3 lone pairs. 3 lone pairs, and this one also we had put 3 lone pairs. Right. Then is 2 minus. So this one is given to you. How to draw the other 2 resonance structures? So only thing is what? You have to rotate this double bond. So if you put the double bond here, then you get one resonance structure. If you shift this double bond to here, you get the other resonance structure. That's it. You can shift the double bond around this, then you can get 2 other resonance structures. So I'll draw here the first resonance structure. I'll shift the double bond to here, then you get the first resonance structure. Carbon. This one I'll make single bond. This one I'll make double bond. This one I'll make single bond, because there are 2 minus. 2 negative charge, that means 2 minus means what? Negative formal charge appears on most electronegative one. That means this can be minus, this can be minus. Right? So, or else you can put the square bracket and put 2 minus, no problem. Remember, whenever oxygen is linked to a central atom with single bond, minus charge appear. What are these? Okay, look at here. This is like a short method. What are the 3 possibilities when oxygen is linked to any atom? There are 3 possibilities. When oxygen is linked to a central atom with single bond, definitely there must be a formal charge on oxygen. That is one possibility. When oxygen is linked to a central atom with first, the most stable one is with a double bond. I'll start with that. Most stable one is oxygen bonded to any other atom with a double bond, then is no formal charge. That is the most stable arrangement for oxygen. When oxygen is linked to the central atom with a single bond, then there will be a minus charge. That means there are 3 lone pairs. That is the second possibility. Third possibility, when oxygen is linked to atom like this, central atom, there can be a dative bond. That means what? Minus charge on this and plus charge on this. It depends on the situation. That is like dative bond. Plus and minus. That example, if you take oxygen, you get ozone, here plus, here minus, dative bond, like that. This is also possible. Understood? Like that. So there are plus and minus possible. A can be oxygen or any other atom. These are the 3 possible, the only 3 ways where oxygen can be linked to an atom. A can be any atom, it can be oxygen or any other atom. So if you put here A oxygen, then oxygen gas here, first one, right? So if you put here, then you can have OH minus, like that. OH minus, this one. So this is ozone, the third one, O plus and O minus, like that. Is that clear? So this is because most of the resonance structures, Lewis structures, so dot and cross diagram, majority of the oxyanions, oxygen is present. Oxyanion means oxygen is present. Most of the compounds, nitrate, nitrite, carbonate, like most of the compounds that you get in the exam for the resonance and hybrid resonance or the resonance structures, but oxygen is there. So then you can have like a short method, the most stable. You have to make the maximum effort to go for the first one. If first one is not possible, you should go for the second one. If second one is not possible, you can go for the third one. Right? So those are the three possibilities that oxygen can be linked to the central atom. So here you can see when carbon cannot form more than 4 bonds. Look at this here, central carbon, carbonate ion. Carbon cannot have more than 4 bonds because expanded octet not possible for carbon. Otherwise you can draw nicely carbonate like this. You can put CO3 like this. You can't do this. Why? Then around carbon 6 bonds, 12 electrons. So carbon cannot have more than 8. Is that clear? Otherwise you cannot have CO3. That's now you can understand why it is CO3 minus. Sometimes CO3 2 minus. Sometimes you can ask why can't it form CO3 minus. Now then you can understand, if I erase this minus charge, what happened? Then I have to make double bond between. This understanding is very important. Why carbonate ion will never become CO3 minus? If you are going to make it CO3 minus, what happened? 2 oxygen form double bonds with carbon. Then only 1 oxygen make minus. Then how many bonds around carbon now? Around carbon there are 5 bonds. Can carbon form 5 bonds? Can't. 5 bonds means around carbon 10 electrons. Then it become expanded octet. Is that clear? So always when you are drawing the resonance structure, don't think about only the resonance structure. So you have to consider all these. Whether my central atom can have expanded octet or not. That also important. But oxygen electronegative charge, the negative formal charge appears on the most electronegative atom, that is oxygen. That is important. When there's a minus charge on oxygen, oxygen form only 1 bond. So this is common to any other resonance structures. So those things, because oxygen is very common in most of the resonance structures. Any questions? So is that clear? Then you can and the other most important thing we have observed in marking also, some students when they draw the resonance structure, they draw this, but they forget lone pairs. Then no marks in the exam. If you forget lone pairs, no marks in the exam. So you have to put the 2 lone pairs here. When there's a minus charge, there are 3 lone pairs to make it octet. Because central atom as well as terminal atoms tends to form the octet. That means 8 electrons. So around carbon 4 bonds, 8. Around each oxygen there are 8. So then altogether this all the atoms here have reached octet. Then what is the next possibility? We can shift this double bond to the other side. Then you can get double bond here and the other two become single with minus charge on oxygen. So again you have to put the lone pairs on this. Lone pairs, when there's a minus charge, there's 3 lone pairs. When there's a minus charge on oxygen, there are 3 lone pairs. Is that clear? Okay. Please raise the hand those who got both these correct resonance structures for carbonate ion. How many of you got all this correct? Very good. Right. All of you got correct this. Right. Done. Then let's move. Then there's one more. They're asking us to draw the resonance hybrid. But remember, almost all the past papers in A-level past papers, they have never asked to draw the resonance hybrid. I have not come across resonance hybrid. They have not asked to draw. Right, but in term test papers, I have seen the school term test papers in the paper. Some teachers they ask the students to draw the resonance, but in A-level paper they ask only the resonance structures and most acceptable Lewis structure. Most of the A-level past papers, structure is a question number 1. They ask to draw the most acceptable Lewis structure and resonance structures, bond angle and all they can ask, but not the hybrid resonance. But anyway, if they give the hybrid resonance, then you should know how to do it. Okay, I'll erase this and let's move to the next part. Have you all got the vaccine from the school? Were you given the vaccine? I think most of the schools, I don't know from the current school, Please raise the hand those who have got the vaccine. Vaccine, three of you got. Sishan, you didn't get. Sishan. Okay, right. Then hybrid resonance. Okay, no problem. Carbonate hybrid. So I'll draw this outside now because I can draw inside the cage also. Carbon. So this double bond possible in all three places. Ne? So then actual structure, no, not one double bond. This double bond, you can draw a dotted line like this. Oxygen, this is the resonance hybrid. And you can put here minus 2 over 3 if you want to get here minus 2 over 3, or you can put out of this bracket you can put 2 minus CO3. Resonance hybrid. I think once Professor Dharnegala like that one of the article I think I shared with you. I can, as I remember, it's Professor Dharnegala resonance structures. Where I'll show that also, then you can have an idea. Can you see this is Professor Dharnegala. Can you see the carbonate ion? Minus 2 or 3. This is the resonance hybrid of carbonate ion. So all the when all the resonance structures are equally stable, we can go for this. If you want, you can take a screenshot of this. This is the chief of your A-level the paper set in Fanel, Professor Dharnegala. So one of his article research, I mean the paper for the university students, first year students. So there is resonance hybrid, but university has resonance hybrid unit, but A-level paper they haven't asked resonance hybrid, only the resonance. When all the resonance structures are equally stable, then you can go for the resonance hybrid. Right. Then I will move back to the paper again. Right. So what you have to do now? You have to put the lone pairs here, 2 lone pairs on each, 2 lone pairs on each, and you have to put minus 2 over 3. Minus 2 over 3. So overall charge, if you multiply this by 3, minus 2 over 3 by 3 oxygen, then you get minus 2. This is the resonance hybrid of carbonate ion. Please raise the hand those who have done the resonance hybrid in the theory class. Have you all done? Resonance hybrid you have done, right? Okay, good. But remember, no need to pay much attention to the resonance hybrid. That is not tested in the A-level paper, right? To draw the resonance, sometimes they can give the resonance hybrid and ask questions, but not to draw the resonance hybrid so far. Yeah, right. Then next one, electronic geometry and the molecular geometry of around carbon in carbonate ion. That means electronic geometry you have to write separately and molecular geometry you have to mention separately. What is the electronic geometry of this? Arrangement of electron pairs around the carbon in the carbonate ion. Yes. And molecular geometry. Molecular geometry is the shape around carbon atom. So both, it will say, since there are no lone pairs around carbon, both take the shape. So it will be what? Trigonal plane. This also will be trigonal plate. Right. The next one, hybridization of nitrogen in nitrate ion. Nitrate ion NO3 minus hybridization. Yes, what is the hybridization of nitrogen in nitrate ion? How to decide that? So the best thing you should know, draw the structure of nitrate. Okay, can you all please quickly draw the structure of nitrate ion? Then it's easy. Structure of nitrate ion. This is the structure of nitrate ion. NO. Okay, let's see nitrite first. Let's see nitrite, then I'll go for the nitrate. Look at the screen, everyone. Nitrate, I'm talking, so I'll write here, right? I'll write here NO2 minus. If you draw NO2 minus nitrite ion, it's like this. It's like this. Minus charge appear on this one. Then there's a lot of oxygen. Then it is angular. Nitrite ion is angular. Then you have to put here 3 lone pairs like this. Then here you have 2 lone pairs. The next one, NO3 minus nitrate. How to get nitrate ion, the structure from nitrite? Now there's a lone pair. Now we have to link one more oxygen. We have to link one more oxygen to this. How to do that? How to do this? Yes. This lone pair, you can make a now can you see here this nitrogen, there are 8 electrons. Can you make one more? Can you make you cannot make double bond. You cannot link this with a double bond. Why? If you put a double bond here, then there will be 5 bonds. 5 bonds means what? Then 10 electrons. Nitrogen second period cannot have expanded octet. Then you can have a dative bond. Then you can have a dative bond. Dative bond. When you write a dative NO3 minus, so then you can write a dative bond. So now dative bond represented by pointing an arrowhead from electron pair donor atom to electron pair accept atom. But we don't, now new syllabus, we don't draw the arrowhead. We put one line and we put plus charge on this nitrogen and minus charge on this. So if plus and minus means it's like a dative bond. Like this. Is that clear? This is how you get the structure of nitrate. Nitrite to nitrate. What is nitrate ion? NO3 minus. This is NO3 minus. Right. Now NO2 minus to NO3 minus. NO2 minus to NO3 minus. NO3 minus. Is that clear? So how many bonds around this now? 4 bonds, no lone pairs. When there are 4 sigma bonds, yes, let's see the answers. Shashank, correct. What about the others? What is the hybridization of nitrogen? The central atom in NO3 minus. NO3 minus, hybridization, not the oxidation number, hybridization. Yeah, oxidation number +5, hybridization sp2o, sp0, sp3. Please raise the hand those who have not done hybridization yet in the theory class. Done, right? All of you have done the hybridization, right? Yeah. By looking at total number of sigma bonds and lone pairs, what matters for the hybridization? Total number of sigma bonds and lone pairs. So when there are 4 bonds, 4 sigma bonds, it is sp3. sp3 hybridization. Nitrate ion, there are 4 bonds. Here, look at this. Hybridization is sp3. sp3. Now I am asking 2 additional questions. I want you to write oxidation number of this nitrogen. Who can tell me the oxidation number of this nitrogen? I mean this nitrogen oxidation number, central atom. There are 4 bonds and one there's a plus charge. Oxidation number and the valency. Oxidation number and the valency, can you tell me? First tell me the oxidation number, second tell me the valency. Yes. Who can tell me nitrate and nitrogen oxidation number and the valency? Oxidation number will be plus 5 here. Okay, look at here. 4 electrons are partially attracted away from nitrogen. So this double bond, 2 electrons are attracted away, each single bond, 1 electron of nitrogen attracted away. So 4 electrons are partially attracted away, 1 electron is completely lost. Then oxidation number will be here plus 5. What is the valency? What is the valency of nitrogen here? Valence is equal to the number of bonds plus number of electrons given out, number of electrons gained, or number of electrons shared. All three should be considered. That means plus charge also should be counted for the valency. Again I am repeating that. Not the shared electrons, the electrons lost and gain also should be added for the valency, should be considered for the valency. So valency also will be here 5. Valency also 5, oxidation number plus 5. Right. Very good. Oxidation number plus 5, right? Valency 5. Okay. So that also they can ask in the exam. But if you get valency of this one, the valency will be 3. Here valency will be 3. Oxidation number will be plus 3. Valency 3, oxidation number plus 3 here. Is that clear? 3 electrons of nitrogen shared, then valency 3. And nitrogen 3 electrons are partially attracted away. Understood? Okay, again, okay, Ransiluni and Chanit is asking again. Okay, valency, this is how you get it. Okay, let's see nitrogen, this nitrogen. Okay, look at here, nitrogen, nitrite, and let's see nitrite first. This nitrite, how many bonds around nitrogen? Okay, this is how you can easily get the valency. Valency equal, I'll give this short method here. Valency will be equal to number of bonds plus number of bonds, 5 bonds and sigma bond, everything, plus any positive charge plus negative charge. Okay, example, if there's 2 plus, then you have to add 2. If there's 2 minus, you have to add 2 for the number of bonds. So all 3 should be counted. I'll give one example. Imagine there's around X there's a double bond, this side single bond, and there's 2 plus. What is the valency now? What is the valency here? 3 bonds and 2 plus, then 3 plus 2, 5. Understood? X valency will be 5. Imagine X has minus charge here. 3 bonds and minus charge. Then what happened? 3 bonds, valency 3, and with the minus charge, it's become valency. Valency has no charge. For the minus charge, you have to increase the valency by 1. Each minus or plus charge, you have to increase the valency by 1. Because valency has no sign. Is that clear, everyone? Very easily you can get the valency around any atom. How? Imagine there's an element, central atom A. Around A, imagine there are 3 bonds with a plus charge. What is the valency now? 3 electrons shared, 1 electron completely given out. Then valency will be 4. 3 bonds, valency 3. For the plus charge, you have to add 1. Then valency will be 4. Understood? So it's the short method. Imagine there's a minus charge on this A. If there's a minus charge on, then also what? For the minus charge, you have to add 1. 3 bonds, well, you have to add 3, 3 plus 1. If it is a plus charge or minus charge, you have to add 1. For each plus charge also we add 1. Each minus charge also we add 1. Imagine I put here 2 minus, then what is the valency? Tell me. 3 bonds and there's a 2 minus charge on this A. What is the valency? Tell me now. If you give me the answer for this, then I will stop this and move to the next one correctly. A has 2 minus charge with 3 bonds. What is the valency of A? Valency will be what? For the 3 covalent bonds, so 3 sigma bonds, valency 3. For the 2 minus charge, I had to add 2 plus 2. Then what is the valency? Valency will be 5. How many of you gave this correctly? I'm asking valency, not the plus minus. No need for the valency, right? Valency will be then 5. 3 plus 2 5. Good, very good. Did everyone understand that? If you want me to explain again, tell me. Who asked that question? How to get the valency? The two of you asked that. No, Ran Silonian. Someone else. Got no. Chanitya and Chanitya, I think. And Ran Silonia, as I remember. Yeah, okay, good. You got it right? Okay. Ran Silonia and Chanitya, did you get it? How to get the valency? Right. Then next one. Some parts there are some very short methods, but I can't give that as a note because it's informal short notes. The formal one is the note, and then you have to write a long paragraph in the theory class. But when you're doing the papers, I'll give some short methods also, if it is applicable for everything. Then I'll erase this. Right. Then next one, let's go to the is spectrum. Right. Spectrum. Hydrogen spectrum. There are two types of spectrum. Absorption spectrum and emission spectrum. Absorption spectrum and emission spectrum. Please raise the hand those who have done the spectrum, hydrogen spectrum, absorption and emission spectrum of hydrogen. Yes, please raise the hand those who have done. Ram Siluni, not done. Okay, Chanitya and Dinen be done, no? Okay, good. So I will explain this, don't worry. Emission spectrum, I think that is general chemistry theory, but I am not going to the theory note now because it's no point wasting time, so you can use the resource book for the theory. When you write the for emission spectrum, what happened? Electrons at the in excited state, when the atoms are in the excited state, they are unstable. Excited atoms are unstable. So excited means electrons transferred from lower or ground level to the higher level, electronic level. So then they return back to the previous level or the ground level. Then that absorbed energy is emitted in the form of radiation. That is called emission spectrum. This emitted radiation, it will give bright light in the dark region. Again, I'll give this something like this. Okay, forget before I give the answer for this. Imagine this is the ground level. So there's an electron. So due to you send some radiation, then what happens? This electron get that extra energy and jump from lower level to the higher level. So when it is in the higher level, when this travel to the higher level, then it's unstable. That is called the excited atoms. Then it undergoes excited state. I put a star here, excited one. So that is like absorption. What happened when this return to the ground level? Again, this absorbed energy released in the form of radiation. That is called the emission spectrum. Emission. For this one, it will be absorption. For this one, it will be absorption. So that's how you get it. But if this electron is completely removed, then it's ionization. It's ionization. Excitation, ionization, emission. Transition. So electrons can transit from lower level to the higher level, but at higher level they are unstable. Now when this electron, when the excited atom, when electron in the excited atom, so the excited atom, when in the excited state is unstable, so when it return, this absorbed energy is released in the form of radiation. If this radiation frequency falls to UV range, it can fall either into IR range or UV range or even visible range. So if this emitted is radiation, if that falls to visible range, we call it Balmer series. If this radiation for the frequency and the energy match with infrared region, then we call it Paschen. If this falls to UV region, we call it Lyman. So UV region higher energy, visible IR low energy, visible high energy. UV high energy, IR low energy. Now let's see how infrared means what? IR means electrons transit from higher level to the third level. For the I'll highlight this. IR you get when electrons undergoing transition from higher level to the third level. Visible region occurs when electron undergo transition from higher level to the second level. Second level. The third level, the second level, this. Then Lyman, or that is ultraviolet UV, when electron undergoing transition from higher level to the first level, ground level, then we call it UV or ultraviolet, that is Lyman series. So then you can post the answer to the chat. Infrared region, we call it what series? That is Paschen. Then visible, it is Balmer. Ultraviolet, it is Lyman. Is that clear? So I hope this one is easy. You can write the answer for this. All three blanks you can easily fill. Then next one is what? You have to draw the lines. You have to draw, indicate, look at the instruction given at the bottom. Indicate with arrows all the electron transitions that could occur. All the electron transitions that could occur. For this, again I highlight arrows. You have to indicate for all the electron transition that could occur between above energy level, responsible for A, B, C. Okay, I'll start with the infrared IR or Paschen. So there electron transition occurs from, look at the screen, from only one level above third energy level, right? So therefore only one is possible. IR only one is possible because no other energy level above that. So therefore only one is possible here. I'll draw this with black. Only one is possible here. Then next one, visible region, what? From upper level to the second level. Then you can draw two possible lines from here to here. Like this. You can use the rule and draw it nicely, a straight line. Can't we draw this the other way around? Is that possible to draw like, can I draw like this? First I draw the long one and then I draw the short one. Is that which one is correct out of this? 1 or 2? This way or this way? Which is most accurate? Drawing this way, 1 or 2? Both the from higher level to the second level? Lyman, sorry, Balmer. Why second? Because you can see left to right energy increase. Left to right now. Number 1, what happened? Energy drop. Because first line more energy, second line less energy. But it's not possible because look at here, in IR to visible to UV, the energy, this way energy increase. That you have to consider here. That is very important. I'll draw line from here to here, what? From Lyman to, from Paschen, Balmer, Lyman, or from IR, UV, energy increase. That's why. Energy increases. That's why I should go for the second one, not for the first one. First one is wrong. Because the first line should be short and the second line should be long. Is that clear? So then you can write here, this one is short and the other one is long, like that. Then third one, how to draw this? Falling of electron from upper level to the first level. That also energy increases now this way. Again I'll draw this arrow from somewhere here. Energy increases from here to here. Increases energy, frequency increase, new increase or frequency increase or energy increase. From IR to UV energy increase. So then I should start from what? Lowest line, this one. From here to here. Second one you can draw like this. So the other way around. From here to here. Second one here to here. third one here to here, like that. So it increases. The last line more energy because more gap. When the gap is more, energy also more. That means gradually energy increases each line. Please raise the hand those who got all three correct here. I mean all three lines correct, like all three regions the lines correctly done like this. You can mark with a red pen. Yes, how many of you got this correctly? How many of you did predicted this correctly? At least one of these correct. Only Seshan raised the hand. Others, you got wrong this. Or do you want me to explain again? First you have to decide from in which direction energy increase. Then you should know the electron transition occurs from where to where. Transition of electron to the ground level or the first level is known as UV. To the second level from upper level, visible. To the third level from upper level, IR. Understood? Next one. Shall I move to the next one? Anyone else will copy down? Dinitmi, one line is incorrect. Okay, no problem. Yeah, if you have got one, so I did it as to energy increase. The other, okay, Chaniti has done the energy increase in the other direction. Okay, so simple mistake. Now you know something, but you have to be more precise in the exam. What matters here actually when you are answering the question, so my advice, not only they are testing chemistry knowledge here, right? Not only the chemistry knowledge, they test whether you are adhering to the instructions given. Some students, they don't follow the instruction, they don't listen to the instructions given, they just do whatever they want according to their will. Then they will go wrong. Or sometimes you are going to install some machine or something when you buy from the market something, you have to install this at home. So it's inside a cardboard box. You need the screw set or something and you have to fix it. Without looking at the catalog or the user manual, you do it. You ask from someone and you do it, or you do it alone. Then it will not be perfect. Therefore, always you have to, so that matters in the exam also. Whether you are following the instructions given or not reading the question properly. So then you will do careless mistakes and lose marks. Therefore, that also very important. Then most of the few MCQs in the A-level paper, you get recall in memory. Then you get some questions like, higher order level questions. And then you get some questions analysis, evaluation, synthesis type, higher order of thinking, higher order of learning questions. So therefore you get all the different types of questions in the paper. Then next one, I'll erase the screen. Next one, question number 5. This is much harder than the previous one, right? This is little bit harder than the previous one. How many of you have done this? Please raise the hand. This is also A-level past paper question. How many of you have answered this? Has anyone done this? At least now can you quickly guess at least one or two lines here? There are two series given here. A series and B series. So hydrogen spectrum. Now first you should decide if there are three series of lines given, then IR, UV, visible, all three they are. Now since there's only two, if one is IR, the other one is okay. Let me explain like this. They have given two consecutively. They have given here A1, A2, A3 belong to the same series. And B1, B2, B3 also belong to the same series. And they are two consecutive series. I think they have given here first 5 energy levels of hydrogen spectrum, 6 lines of the emission spectrum of hydrogen. First 3 lines of each. Okay. So if you take here this one IR, this should be what? Either visible or UV. Because how to decide this? Look at the gap here. Gap between the first two level A1 and A2 gap is less. B1 and B2 gap is more. That means what? This one energy should be more. B series energy should be greater. Higher energy, lower energy. That's how you decide here. By looking at the first two lines, you can decide it. This series has higher energy than this one. This one has lower energy. Is that clear? This one has higher energy and this one has lower. That is the first prediction. By looking at the gap between the first two lines. By looking at the gap between the first two lines, you can decide this. This one has higher energy. Is that clear, everyone? That is number one. So example, if this is UV, this should be what? Before UV you have visible. Visible. Or else you can have, if this is visible, this should be IR, lower than that. One of this combination. But the problem is this. If this is IR is what? Falling of electron from what? Higher level to which level? Third level. If it is IR, can you draw three lines here? Can't, because from here to here only you can draw only two lines. Maximum two lines you can do here, but there are three lines here. You can draw only A1 and A2. Then A3, now the next one you can't draw. That's why you have to omit this IR here. IR is not possible here. Why? Because we can't draw three lines. IR means falling of electron from higher level to the third level. But let's see whether we can draw three lines with, then I will erase this. IR and UV, visible, not possible. Then let's go for visible and UV. Visible or Balmer and Lyman. Then I can draw, let's see whether we can draw three lines. So this way energy increase. In each series, in this direction energy increase. That is the other most important. This is one of the hardest question they have given in LL past papers, right? From spectrum. This way is increase. This way energy increase. This series also energy increase. Why? When the gap between the lines decrease, energy increase. So if you want to write here, when gap between the lines decrease, when gap decreases, comma, energy increase. When gap decreases, energy increases. Energy increases. Is that clear? Again I am repeating. When the gap decreases, comma, energy increases. Comma, energy increases. When the gap decreases, energy increases. That means B1 to B3 energy increase, A1 to A3 also energy increase. Right. That is okay. Chaniti, I did it. Okay, that is there. Okay, please raise the hand. Anyone done this? Like, can you all try now without my help? Can you draw the lines now? If I give everything from the beginning to from 0 to the end, then I will improve, not you. So therefore, I gave a start now. Can you all draw the lines with the pencil in your paper? I mean, you can erase if you get this wrong. With the pencil, can you draw the lines, the respective lines for the electron transition from higher level to lower level for the A1, A2 parallel to A1, draw a line. Parallel to A2, draw a line. From higher level to which one? So we took now visible and UV. That means to the second level, no? Can you try now? Or else I will give the okay, you can draw a line. You can annotate on my screen. Any volunteers? You can annotate on my screen. I have given the annotation for the others. Even one can draw in the A series and the other student can draw in the B series simultaneously. You can annotate on my screen. You can draw a line and see. If you have not done that, then I can erase it now. If you have done it wrong. Yes? And I'll draw on my screen the lines. Try. Yes? Any volunteers? You can draw a line from upper level to what? Visible means what? Palmer means what? Falling of electron transition from higher level to the second level. Three lines you have to draw. Or shall I draw this? Okay, very good. Dinath is trying to do it. Can just draw a line with the mouse, yeah, because no need right. Yeah, correct. You good start, Dinatmi. And you just draw at least like this halfway at least, and then can draw the other two, A2 and A3. Okay, A1 you had done. Ah, okay, okay, right. So I'll draw A1 to 3 to 2. So I'll write here, highlight here, A1, A1, 3 to 2. So I'll label this, then this is for A1, nah? A1. Then next one, Bhamane, so falling of electron from high level to the next second level. Then next one I to A2 from here to here. This is for A2. A2, I'll draw here A2. The next one A3. A3 I'll draw from here to here. A3. A3. Now this is the most important thing. Can you all see here this A1 to A3 gap is more. Here also A1 to A3 gap is more here. This gap is more. This gap is less. Is nicely matched here, right? A2 to A3 gap and A1 to A2 gap is more. This gap is more, right? I put here X and Y. Here X, here Y. X and Y. This will be X. This will be Y. It nicely matched with the lines gap. If I draw the other way around, what problem will arise? This is a hard question. If I draw, okay, one can do this way also, no? A1, A2, A3 like this way also. I draw a higher level to the second level. I draw this way. This way. Then also it's higher level to the second level. Then also it belongs to Bhamani. Why this is wrong? A1, A2, A3. If I do this way, why it is wrong? Then A1 and A2 gap is less here. A1 to A2 gap. This gap is low. This gap is high. That doesn't match with the lines given there, because first two lines the gap is more. Here in this one the first two lines the gap is less. Can you all see this gap? I'll highlight this with pink. This is the gap, but here the gap is more. A2 A3 gap is more. That doesn't tally with the lines given here. Is that clear, everyone? So that's why we cannot draw this way. We cannot draw it. I will erase that. Understood? Clear? This is A1 to A2 gap is X. This is just to understand, no need to write X and Y in the exam. So this is X and Y. Understood? Any questions? Did you all understand the first three lines? A1, A2, A3? Or do you want me to explain again? Please raise the hand those who have done this way and got this correct. Please raise the hand those who have done this way and got it correct. Anyone done this at home and got it correct like this way? Very good, right? Okay, very good. Then B1 to B3, how to draw the lines? Now this is UV, because how did we decide first series U visible and second series UV? Because first two lines the gap in A1 to A2 gap is less than B1 to B3 gap. B1 to B3 gap is more, means what? It has higher energy that series. So I'll use different color for that. So I will draw with different color. I'll use red. B1 I'll draw first. B1 higher level to the first level. So I can draw like this. B1 like this, right? Then B2 I'll draw it here, parallel to that, from upper level to the first one. Then next one I'll draw B3 like this. It nicely matched. This one the gap is more, right? Here you can see the gap. This gap is more than this gap. So if you put here A and B, this will be, I'll say, let's say A, this one will be B, then this is A and this is B. And can you see here AB? So I put here B1, it's a different color, this is B series. B1 to B2, this is B2 to B3, right? B2 to B3. So B1 to B2 or A1 to A2 gap is more here. B1 to B2 gap is more, right? More gap, more energy between, the difference is higher. That's why this gap is more. That's why we have to take B series, energy is higher. First two lines the gap is more. Again I am telling, compare the gap between the first two lines and then decide which series has more energy, right? So if you take B as UV, then this should be visible. You can't go for IR A series because you can't draw three lines then. Any questions? If you want to get label, now this is B1, B2, B3 like this. Problem is this A-level structure is a paper. This is given in the A-level structure is a type paper. So if you do a mistake, then what happen? If you after drawing with the pen, you can't correct it because you cannot use Tipex. It's difficult to erase. So you have to try this with the pencil first, and then if you have done a mistake, you can erase it. Please raise the hand those who got both this perfectly correct, A1 to A3 and B1 to B3 done at home and got it correct like this. Only one series got correct. Those who got only one of this series at least. Chanitya and Dinitya, right? Good. Okay, right. Any questions? So there's one more part you had right at the bottom. There's one more question. So draw the arrows from A1 to A3. Now remember in the exam, the marking, they check the direction of the arrowhead matters. Direction of the arrowhead matters. So then it should match with what? It should align with A1, A2, A3. If it is not aligned with A1, A2, A3, at least you have to label like me. I tried my best to draw it aligned with that. If not, you have to label that A1 to A3. Understood? Then let's move on to the next part. There's one more part. Strike of inappropriate word. Now that's why I'm telling how to write the answer. Now I have seen sometimes in marking what happened. Some students underline this. Correct one, underline. But what is given here, that's why I told adhering to the instruction given also important. So what is given here? Strike off the inappropriate word within the bracket. That means you have to cut this with one line. So if you underline, then what you have done is correct. You have understood it. You know the answer, but you have not. Please don't write all what you know, or don't do you all what you are wanting to do in the exam. Do for what they ask. Don't write all what you know. So you have to write only for what they ask. That is one of the biggest mistakes the students lose marks, because they have enough knowledge to go fast, but they are not adhering to the instructions given. Right. So what should be strike off this now? Frequency of the spectral lines increases or decreases from A to B. Answer is what? Increases. Then which one we should omit? Decrease word we have to cut, no? Answer is increase. Then this one I'll cut with a line like this. That's how you do it. Is that clear? Please raise the hand those who got this, the last question, the part 3 correct. In this one, this is actually a passable question. They ask him clearly label. Here the first two parts check. You have to label it. Clearly label and draw the 6 arrows. Draw 6 arrows to show the electron transition and label them as A1, A2, A3. That is the end of revision number 3, the RG3. RG3. Right. Then let's move on to the next one. Any questions? So the next one, RG4. No, RG5, sorry, RG4 we finished. RG5 we had to start. Have you all done this today? I think in the morning, or sorry about that. Next time I'll post little bit early. RG6 I'll post by tomorrow. Then you have enough time to do it now. Please raise the hand, at least those who have done the first few MCQs here. Have you all done at least the first few MCQs? At least first page MCQs if you have done, that's good. Chanitya and Ransuloni done, no? Maybe you might have class. Yeah. Maybe when you have classes, then you don't have time to do it. No problem. We'll do like this. You can quickly guess the answer and post the answer. Those who couldn't do this, that's all right. You can quickly post the answer to the chat if you can guess the answer now, right? Otherwise, just no point of just marking the answer without knowing what's the question even. Now, first MCQ, right? If you have not got a printout of this, write separate in your right book. RG4 revision number, not 4, no, this is 5. Sorry. Yeah, revision number 5, RG5 MCQs, the answers. Yeah, you can post the answer to the chat if you want. I told you, can remember that there's only one group in the periodic table which contain all three physical states: solid, liquid, gas. What is that? Group 7. Mercury also liquid. Bromine also liquid. Okay, please write everyone, separated right here, non-metallic, okay, metallic liquid is mercury. What is the metallic liquid? Mercury. Then number 2 I'll write non-metallic liquid. Non-metallic liquid will be bromine. Right? So those are the two liquids in your syllabus: metallic liquid mercury, non-metallic liquid. And the other most important thing, the only group in the periodic table which contain all three physical states. That means what? Solid, liquid, gas. That is group 7. Fluorine, chlorine, bromine. Actually, this is a A-level pass question. Fluorine and chlorine gas. Bromine is a liquid and iodine is a solid. Iodine is solid. Fluorine, chlorine gas. Bromine is liquid. Iodine is solid. So this is the only group which contain all three physical states. So then what is the answer? Can you quickly post the answer in the chat? Because periodic table also given. Dinetmi gave the answer. Sishan gave the answer. Chaniti gave. Ransilani also gave. Yeah, actually answer is 5. Sishan answer is not 3. Yeah? 3 contain 2 liquids and 1 solid. Both this liquid and this is solid. Sulfur is solid. But they are asking all three states: solid, liquid, gas. So then you get fluorine, chlorine, solid, gas, liquid, solid, gas, liquid, solid, gas, liquid, solid. Answer is second, right? Not 5. Because these two gas, I put gas and this is liquid, bromine liquid. Here, krypton gas, chlorine also gas, and mercury liquid gas, liquid, liquid solid. This will be oxygen gas, bromine liquid, iodine solid. They haven't given respectively, therefore no need to get this respectively. This is actually nitrogen gas, potassium solid, argon, silver solid. So what is the answer now? Sorry. Yeah, fluorine and chlorine gas. No, I wrote that. Yeah. So fluorine and chlorine gas. Yeah, I put fluorine and chlorine gas. Answer is second, right? Why did most of you put the third answer? Sorry, fifth answer. First time those who have put the answer, you have put the fifth answer. So the answer is second, right? Answer is second. not fifth. This is the answer. So all three you get solid, liquid, gas. Please raise the hand those who got this correct. Those who had done this at home and or before me, those who had got this correct. How many of you got this correct? None of you. Right? Okay. Then let's see the next question. Like next MCQ. Shall I raise the screen? Anyone still copying down anything? Please raise the hand. Right. Then let's move on to the next question. Question number 2. Number of this also LL pass question. Number of electrons and neutrons in Mg2 plus respectively. Yes, what is the answer? How to get the answer for this? Can you quickly post the answer to the chat? Question number 2. Chaniti, Sishan gave, Dinatmi gave, answer Runi? Yeah, very good, very easily. So I won't waste time on this. Electrons 10, neutrons 13, no? Neutrons 13 because magnesium they got 25 here. So answer will be third, right? Answer will be third. Correct, very good. Ransuluni correct, Dinatmi correct, Sishan correct, Chaniti also correct, very good. All of you are correct. Then next part. Question number 3. Okay, what is the answer for this? Atomic number 25 and it formed +1 charge ion. Number of unpaired electrons. How many unpaired electrons in this? Yes. What is atomic number 25? Atomic number 25. So if you get the IUPAC periodic table, atomic number 25 is manganese. Atomic number 25 is manganese. D5S2. D5S2. Look at the screen. D5S2. D5S2. That is manganese. Periodic table is given in the exam. Mn manganese atomic number 25, then you get the outermost configuration D5S2, 3D5OS2, 3D5OS2, right? So when it become Mn plus, what happened? It become 3D5OS1. Then how many unpaired electrons is very easy. You get 6 unpaired electrons. 1, 2, 3, 4, 5 and here 6 unpaired electron. Okay. What is the answer for the question number 3? Seshan wrong. Ransiluni correct. Chaniti Dinatni correct. Chaniti second time you have put Chaniti correct. Okay. You put the answer like no need to type the answer. I mean this question number 3 dash answer is fourth like that. No need to type the entire answer like 6 electron like that. Yeah. And, if everyone is putting the answer in the same format, it's easy for me to read. So what you should write here, the question number 3, no need to answer, just write 3 dash answer is fourth answer. Fourth answer contains 6 unpaired electron like that, then it's easy, right? So answer is fourth. So it's based on electronic configuration. Next one, question number 4. I'll erase this. Fourth MCQ. Third ionization enthalpy or third ionization energy maximum. Third ionization energy maximum will be which group? That means removal of third electron most difficult. Removal of third electron most difficult from which group elements? Third period, group 2 or group 3 elements? Group 2, they form easily 2 plus. Ne? So when it's going to become 3 plus the problem, Mg this up to second ionization is low. But Mg will never become Mg3 plus. Why? This is the third ionization energy. Third ionization energy become very high because that third electron is removed from inner shell by breaking the noble gas configuration. So right everyone, third ionization energy maximum group 2 top. Third ionization energy maximum group 2 top. So what is the answer? Yes, can you all post the answer to the chat? Sishan correct. Chaniti correct. Transilini not magnesium. Group 2 top whom? Group 2 top you get? Group 2 top you get what? Beryllium, magnesium, calcium, strontium, barium. Who is at the top? Not magnesium, beryllium. See whether beryllium is there. If beryllium is not there, the answer is magnesium. Is that clear everyone? Beryllium, magnesium, calcium, strontium, barium. So the answer should be what? Answer should be beryllium. Yeah, answer is 5. Not 4. Okay. The next one, question number 5. Shall I erase this? Then let's move on to the next question. Question number 5. Question number 5. Subshell with n equals 6, L equal to can accommodate maximum how many electrons? Yes. How many electrons can this accommodate? N6. L2. L2 means what? L0 means S. L1 means P. L2 means D, right? So that is 6D. 6D can accommodate how many electrons maximum? Answer is Wait, I'll upload this again, get the paper, because suddenly like there was a sudden power failure. Yeah, okay, now okay, I will share the screen again. Can you all see the screen now? Pen, right? Okay. There was a sudden power failure, right? I connected with the mobile hotspot. Okay, so we are discussing about question number question number 5. Yeah, 5, the answer is 10 and 6D. So then the answer will be 10 electrons, right? Did you all get this correct? Then question number 6. Question number 6. Yeah, can you quickly post the answer to the chat? Sixth one, what is the answer? And now, who has given this fifth answer? Now, Chaniti, answer is 5, the entire thing, like, sixth energy level, 6 and that is 6 squared, 2 into 6 squared, 36 into 72 electrons, correct? That is in the entire sixth energy level. Okay, Chaniti. But they asking 6D. Understood? Subshell, not the main shell or the energy level. Okay. Then next one. Question number 6. Can you quickly post the answer to the chat? Sixth one. Chromium in the ground state, number of occupied orbitals. Number of occupied orbitals. You have to be very careful. Read the question carefully. Otherwise, you will get this wrong. Question number 6. Number of, I'll highlight here, occupied orbitals. They don't specify which orbital. Occupied orbital means electrons containing orbitals. Chromium atomic number 24. You can quickly write the configuration. Okay. Chromium atomic number 24. So then you can write here 1s2, 2s2, 2p6. Okay, wait a second. This is chromium Cr, atomic number 24. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 4s1. Right, 3d5 4s1. Now number of occupied orbitals. Okay, this is only one orbital in s orbital. S orbital. This also s orbital. One orbital. P has three orbitals. 1, 2, 3. Three orbitals. 1, 1. Then this one s1 orbital. P has how many orbitals? 3. T has, you can pause the answer to chat quickly if you are done at home. 1, 2, 3, 4, 5. 5 orbitals. This one contain only one orbital. So if you add all these, you get the answer. 1 plus 1 plus 3 plus 1 plus 3 plus 5 plus 1. What is the total now? What is the total? 1, 2, 5, 6, 9 plus 5, 14, 14 plus 1, 15. No? There are 15 occupied orbitals, isn't it? Huh? Isn't it? 15, right? How many of you got the second? Then the answer is second. Answer will be second. There are 15 occupied orbitals. There are 15 occupied orbitals. So the answer is second. Answer is second. Seshan Dinatmi correct. Seshan first put the fourth answer, then change to the second answer. Ransiluni correct. Chaniti, you put the third answer, right? Chaniti? Third answer 7. Why did you take 7? You took only the D. And only the last two, 3D and 4S, I think. Did you get it, Janiti? Right. Then let's move to the next one. I'll erase the screen. Question number 7. What is the answer for the 7th MCQ? Can you quickly put the answer for the chat to the chat? Yes, what is the answer for the 7th MCQ? Opposite spin. Having opposite spin. Yes. Parallel spin and opposite spin. That means electrons in an orbital occupying opposite spin, because parallel spin more repulsion is unstable. In parallel spin is unstable. So when they are in opposite spin, that is more stable, right? That is more stable. Yes. Answer is, yeah. Some of you have Chan given answer. Chaniti gave the answer. What about Ransiluni and Dinatmi? 7th MCQ. Can you pause the answer? Ransiluni and Dinatmi, only two of you give the answer. Chaniti and Chan only give the answer. Because I am expecting the answer from everyone. Right? I am expecting the answer from everyone. Right. Okay. So answer is second. Very good. All of you are correct. Answer is second. Answer is second. Police exclusion principle. So Shana and Chaniti correct. Then next one. Question number 8. Question number 8. Charge mass ratio of cathode rays depends on what? Cathode rays, the answer to the chat. Yes. What is the answer for the 8th MCQ? Can you all see the screen? Yes? Answer is nature of the gas inside the tube, pressure of the gas inside the discharge tube, material of the cathode, shape of the cathode. There's one more answer. 5th one, the answer is none of these. You can guess the answer this. Actually, cathode rays means electron. Cathode rays consist of electron. Electron has a charge and the mass, right? So it depends on what? Whatever the material used, the electron is electron. Whether electron is coming out from the platinum or gold or silver, or whatever the cathode or anode, the metal rod, its electron has the same charge. What it's irrespective of the element or the atom, electron has the charge of the electron will not change with the matter, right? Mass of the electron will not change with the matter. The material will not affect. Pressure of the gas and the nature of the gas will not affect. Anode rays, yes. Anode rays, that will affect. The shape of the cathode also will not affect. So the answer is 5. Right? Seshan, correct. Ransulani, why did you give the second answer? No. Actually, to produce cathode rays, the pressure should be reduced. I don't know if they have done the cathode ray tube experiment. You have to reduce the pressure to produce cathode rays. So at high pressure, cathode rays will not change the properties. Whatever the gas, actually what happens inside the cathode ray tube, hydrogen gas, if you have hydrogen gas inside this cathode ray tube, what happens under high pressure is become atoms, right? Atoms. So then hydrogen atoms then is ionized, 2 hydrogen atoms, so this bond is broken down, then it's become H plus electron. So then what happens, these electrons get accelerated from the, if you take the cathode ray tube, the anode and the cathode, you apply here high pressure and high voltage here, 2 electrodes, here you apply high voltage and you reduce the pressure inside the cathode ray tube, low pressure. What happened? What are the 2 particles inside this? You have H plus and electron. H plus and electron there. So electrons are negatively charged. So what happened to these electrons? Okay, forget about the H plus. So electrons are there inside. These electrons, if you side this side minus, this side plus, right? So this is negative electrode is called cathode. Positive one is called anode. This is plus anode. Now electrons will travel from cathode, repel, because this side minus repulsion. So electrons get attracted from negative to positive, from the cathode towards the anode. Anode is positive. So these fast moving electrons from the cathode towards anode is known as what? Cathode rays. Actually, cathode rays consist of the particle electron. Electron is negatively charged. So since it is coming from the cathode, it's called cathode rays. Actually, cathode rays, electrons are not emitted from the metal in the cathode. Electrons are produced due to the ionization of this hydrogen gas. That is the most important thing I want you to understand. How electrons or cathode rays are produced inside this tube? There must be a gas in it. If it is a vacuum, then no cathode rays here. Right? So cathode rays are produced. So whatever the gas, when it's ionized, electron is electron. Electron, the properties won't change. Is that clear? Pressure of the gas won't affect. Nature of the gas also will not affect. And the material of the cathode also will not affect. Whatever the metal that you use for the cathode, electron is coming due to the ionization of the gas. The shape of the cathode also will not affect. Is that clear? Now what happened to the H plus? Actually H that is called cathode rays. H plus is what? Proton. H plus has H plus atomic number 1. So it has just one proton. No electrons, no neutrons. Hydrogen H plus is also called proton. That's why H plus is equal to proton, because it has just one proton. Therefore H plus ions are repelled from the anode and it will get attracted towards the cathode. Cathode is negative, H plus positive. If you use a hollow cathode, they will travel through these holes of the cathode, porous cathode. Then it become anode rays. So anode rays consist of what? H plus. Anode rays means positive rays. Positive rays consist of H plus. Cathode rays consist of electron. In others, proton. So that led to the discovery of proton. The positive rays, cathode rays led to the discovery of electron. Something like that. Is that clear? So is that clear? The answer is 5 now. Everyone? Dinatmi, you put the third answer. Answer, you gave the second answer. But answer is 5, right? None of these cathode rays, the charge or the mass of the cathode rays. But anode rays different. Anode rays for the positive rays, it depends on the gas inside. Because H plus, the mass and the charge different from, imagine you put here helium. Then helium become H, imagine He2 plus or plus. Helium, the mass and the charge different from hydrogen. But electron will not change. Electron, the mass and the charge will not change with the gas. But can you all please write that? Charge mass ratio of the cathode rays or the electron is independent of the gas. But anode rays, it will affect. That will change. That is very, very important. That is very important. Understood, everyone? Is that clear? Shall I erase this? Right. Then let's move on to these are basic. So all our, so on what factors about the anode rays? Anode rays depends on the gas used inside the cathode ray tube. Anode rays, the charge and the mass changes with the gas used inside the cathode ray tube. Anode rays means positive rays. It depends on the type of gas used inside. Only on that it depends. But cathode rays, none of this. Cathode rays, whatever the gas used, cathode ray is electron, electron is electron, whatever the element used, the gas used. Is that clear, everyone? Okay, I'll erase the screen now. Question number 9. Principal quantum number of atom represent what? Yes, can you quickly tell me the answer? What is principal quantum number? N. Principal quantum number means N. Principal quantum number means N. Yes. Energy of the orbital. Okay, so what matters here, that is called the principal. So it can be 1n, 2n. One. Okay, I'll give one example. N. So if you write 1s and 2s, is the what can you figure out from 1s and 2s? So here n is 1, here n is 2. When n is 1, so I'll write 1s. When n is 2, I'll write 2s. Yes. So which one has, imagine like here you have 1s1 and 2s1. Which electron has more energy? Electron in 1s or 2s? So by looking at the principal quantum number n here, we can decide what? Average, the energy, right? 2s electron has more energy than 1s. Is that clear, everyone? Energy of the electron increases now when moving away from the nucleus. So if you take 1s this much, 2s will be what? The size will be more than that. It's common sense. 2s will be more than that size. So if you take this one 1s, this will be 2s. What are the informations that you can get from this? Chaniti gave 5th answer. Deshan gave 4th answer. Ransiluni gave 5th answer. Aseshan again changed the answer and gave 5th. Okay, after my explanation, you understood this, right? Answer is what? Both 1 and 4. You can have an idea about the size of the orbital also, correct? Energy also you can get an idea. You can get both energy and the size, because when it's become 2s, size is more than 1s. 2s orbital, the size is more than 1s. So therefore size and energy both you can get from this. Principal quantum number represent both size and the energy. Answer is 5. Right, good. Then question number 10. 10th MCQ. Nucleus, the number of neutrons is okay. This is a very oral chemistry like question, right? Oral type question here. Can you, this also actually I think one of the school term test papers they have given, like one of the top school, as I remember these ones. A-level paper also I can remember. Anyway, what is the answer for this? Neutrons, how to find? 235 minus 92. Then you get the neutrons. How many neutrons you get when you subtract? 3. 13 minus 4, 4, right? 143. Yeah. Answer is 3. Very good. Sorry. Answer is 3. Very good. Yeah, Ransiluni, there are 3 other quantum numbers, L, ML and MS. So I have put questions from them also. I'll explain about that. Yeah, when it come to those questions. Yeah, anyway, I'll be explaining. Don't worry. Then question number 11. 11th MCQ. Yes. They have given number of electrons, atomic number 43. Atomic number 43, check the periodic table, which element and to which group it belongs. It from +4. And electrons in the last sub-energy level. They are asking electrons in the last sub-energy level. Last sub-energy level, how many electrons? So my advice, when you read the question, please pay attention to the question word as well as active words of the question. Right? Question word as well as active words of the question. Right. Can you? I'm waiting for your answers. Only Seshan and Chanita gave the answer, and Ransiluni gave. Okay. No. Only Chanita gave the answer for the 11. What about the others? I'm waiting for your answers. At least can you quickly look at the periodic table? Look at the periodic table. What is the atomic number 43? Look at here. It's there. Look at the screen. 43rd one is what? Technetium. Here. Look at this. Technetium. Manganese. So the same group both. Therefore, this is ending in 3D54S1. Then technetium will be what? 43 will be what? 4D5 5S1. 4D5 5S1. That's how you get it, right? Then they are asking last sub energy level, how many electrons when it become +4. +4 means what? 1 from this, 3 from this, then you get 42. You get 42. So this is for manganese. Atomic number 25, then this is TC, text atomic number 43. So this become this is the ground state now. When this become TC4 plus, it become 4D. First one electron going from 5s and 3 electrons going from 4D. Then 4D become 43, no? 42. 42 and 5s not. 3 from D and 1 from S. Then it's become, that's how it become 4 plus. Yes. Yeah, so what is the answer then? Can you quickly post the answer to the chat? Only Chaniti Srishan gave the answer. Answer is 11th MCQ answer is 3. Last sub energy level is 4D. 4D. Is that 43? 43. Yeah. Sorry. I have done a big mistake here. Sorry about that. Yeah. So this should be 5s2. No, sorry about that. This should be 5s2. Sorry. Yeah. 5s2. This is also 5s2. Yeah, because it's not chromium, it's manganese. So then it's become 3D3. Yeah, correct. Yeah, you all are correct. Yeah, very good. So it should be 43 because these two going out, and then from these 2 electrons going out, then 43 will be left. Yes. So then answer is 3. Very good. Okay, all of you are correct. Right, done. Answer is 3. Yeah. Only 3 electrons in the last sub energy level. Then next one, question number 12. Question number 12. Principal valencies of the elements with atomic number 34. Again, quickly look at the periodic table. Atomic number 34. What is the atomic number 34? Take the group, then you can easily get the valency. Atomic number 30, because LL, both MCQ and essay type paper, you get the periodic table. Atomic number 34 is selenium. Atomic number 34 is selenium. Right? Selenium. Group 6. Group 6, what are the common valencies? 2 and 12th MCQ. Can you quickly post the answer to the chat? You can write in front of atomic number 34, it's selenium. Yes. Answer is second. Very good. Yeah. Chaniti correct. Ransiloni correct. Yeah. Dinit also correct. Very good. Answer is second. Question number 13. I'll erase the screen. 13th MCQ. Which one of the following is the first ionization energy lowest? First ionization energy highlight, lowest highlight. Yes. Which one? I told you at the beginning today, I did a similar question. I told you first ionization energy lowest, group 1 bottom. Which one is group 1 bottom here? Which one is the answer? 13th MCQ. Very good. All of you are correct. Answer is 5. Francium is the group 1 bottom. Francium is in group 1 bottom. Then question number 14. False statement about hydrogen. Emission spectrum of hydrogen. Yeah, can you quickly post the answer to the chat? Hydrogen spectrum, false statement. Now, I think all of you have done this, right? The spectrum and everything. Most of the questions that we discuss in this paper today, I think relevant. It's related to your first chapter. It is related to your first chapter. Yes. Answer is Okay, good. Most have done it correctly. 14th one, Chanit gave first, Dinitmi gave fourth, Zishan gave second. Different answers. Is that hard? Again, I am playing the incorrect statement they asked, right? Incorrect one they asked. Ranasiruni gave first. First and second and fourth. Okay. So, false one is actually the answer is first. Ransiluni correct, Chaniti correct. Only Ransiluni and Chaniti correct. Why? Hydrogen emission spectrum is not a continuous spectrum. That is a line spectrum. First statement itself false. Please write everyone. Both emission spectrum as well as absorption spectrum of hydrogen or any other, that is a line spectrum. That is a line spectrum. Why we did lines today? Today also we did some structured setup question. It's a line spectrum. If you want to write, can you give me an example of a continuous spectrum? Continuous spectrum, naturally occurring continuous spectrum. Rainbow continuous spectrum. But this is some lines are missing now, like you don't get a bright like dark. You have done on this bright line in dark region or dark lines in bright region, like that you get a line spectrum. So H alpha, H beta, H gamma, the first three lines you can label H alpha, H beta, H gamma, the hydrogen spectrum, the visible region, the first three lines, right? H delta, like that. Then position of the frequency of range and increase of frequency, yes, gap bit, yeah, that increase, that's true. All lines in the emission incident not belong to the visible, that's also true. Yeah. Did you get it? Or do you want me to explain it again? Right. Then next one, question number 15. 15th one, that is again from general chemistry, your first chapter. Yes. 15th MCQ, what is the answer? Can you quickly pause the answer? Chemists who directly involve EM ratio of cathode, neutron in nuclear radius and radioactivity. Okay, only Shanita gave the answer. Ransiruni gave, Sishan also gave. What about Dinatmi? 1, 1, 1, 2. Three of you have given first answer, one have given second answer. Now let's see. First or second? Radioactivity discovered by Henry Becquerel, no? EM ratio Thomson, neutron Chadwick, and nuclear radius Geiger and Watson. So the answer is second, not first. Answer is second. That is directly recalling the previous knowledge. Like no calculation, no analysis, no evaluation, directly the recalling the previous knowledge. So mostly A-level paper, first MCQ, they can ask a similar question like this. A-level paper, the first MCQ, they can ask a question like this. Right. Then question number 16. Yes, what is the answer for the 16th MCQ? 16th MCQ, what is the answer? Very easy. This is also A-level pass-through question. Very easy. So I don't need to waste time on this. Session, you are repeatedly telling the answer. Like, I mean, type in only once enough. I'm getting all this. So sometimes you are getting the same answer like about 5-6 times. So I think you are typing the same answer, entering so many times. So no need to do it, only once enough. Okay, Seshan gave third answer. Ransun gave fourth. everyone should give the correct answer for this at least, because it's very easy, like 16th MCQ. Chaniti gave 4th, Dinetmi gave 4th, Sishan gave 3rd, and everyone else gave 4th except Sishan. Answer is 4th, right? Because why did you get 3rd answer, Sishan? Because they are asking electrons and protons, right? Protons won't change. Remember, proton number, when an atom become an ion, proton number and neutron number no change. If you want, you can write that. You can put a stand right. When an atom become ion, ion means what? Positive ion or negative ion. It can be positive or negative. Positive ion or negative ion. Which subatomic particle undergoing changes? On when an atom become ion, only when an atom become ion, only proton and only electron number will change. Only the number of electrons will change. Only electron number changes, but proton and neutron and atomic number no changes. Proton, neutron and atomic number no change. Very, very important. Atomic number no change. No change. So atomic number is 12. Atomic number 12 means what? Atomic number 12 means protons and atomic number no change. That means protons remain 12. Not 13. 12. So this is the only answer I think which contain 12 protons, right? Protons will be 12 because first you have to get electrons. So respectively, right? First electrons, second protons. Electrons become what? 12 become 10. Why? Because 2 electrons are lost. Answer is 4th. Answer is 4th. Is that clear? Right? Suzanne? Then question number 17. Please write, when an atom become an ion, proton and neutrons no change. Proton, atomic number and neutrons not undergoing any change when an atom become an ion. Positive ion or negative ion. Question number 17, hurry up. Question number 17, can you quickly tell me? Ionization energy, first ionization energy, you have to get them in the increase in order. Check the periodic table, the position of this. First ionization energy lowest, this potassium lowest. Lowest potassium. Then if you take the zigzag pattern also, you can have an idea about this. You get a zigzag pattern like this. Right? So you get group 8, 7, 6, 5, 4, 3, 2, 1 like this. What are the groups? I'll write quickly if you want. You can put them. You can check group 1, 2, 3, 4, 5, 6, 7, 8. Right. So out of this, if you place them in the correct position, then you can have an idea. Here the period also matters. Down the group, the ionization energy decrease. So fluorine is 7th position, right? Fluorine is here, so it has bit higher value. Then phosphorus group 5. Phosphorus is here, group 5. Nitrogen also group 5. Nitrogen and phosphorus same group, group 5. Group 5. Then sodium, potassium in the same group, group 1. I put Na and K. Then what is left? Magnesium group 2. Magnesium group 2. Fluorine, nitrogen, phosphorus. Okay, these are the elements. So lowest potassium, I put numbers here. Number 1 potassium. Second lowest what? Sodium, no? Sodium. You can quickly post the answer before I tell. 17, Chaniti, Dinetmi and Seshan give one similar answers. Then Chaniti and then who didn't post? Dinetmi? What is the answer? Dinetmi also gave. Who didn't give the answer? Ransiruni. Ransiruni, what is the answer? Second, okay. Second. Potassium, sodium, magnesium. Potassium, I put numbers here. Number 2, magnesium. Second. Then number 3, you get this one, magnesium. Number 4, nitrogen or phosphorus. Number 4, Next highest, nitrogen. Then phosphorus. You have to go from lowest to highest. No, then the other way around. Sorry. And phosphorus lower than nitrogen. Sorry about that. You have to get after magnesium. You get fourth phosphorus, then fifth nitrogen, because nitrogen the value is higher than phosphorus. Then last one you get fluorine. So this is the order. Look at the periodic table. The position also matters. Lowest potassium, then sodium, then magnesium. After that phosphorus, then nitrogen, then fluorine. I put, look at 1, 2, 3, 4. I put here. And it's easy to understand. Potassium, sodium, magnesium, phosphorus, nitrogen, and fluorine. What is the answer? 1 or 2? 1 or 2? Answer is 2. Right? Chani, the answer is 2, right? Yeah, okay. Okay, all of you are correct. Second time Chaniti also gave the correct answer. Question number 18. Okay, Seshan already given the answer. 18th one. What about the others? 18th one. Periodic table contain highest number of non-metallic elements. Highest number of non-metallic elements. Yes, which one? Highest number of non-metallic elements. Yes, yes. Answer is okay. Look at the periodic table. Highest number of non-metallic elements, which period? Period, another group. Non-metallic elements you get highest in first period or second period or third period. Look at this. I'll highlight here non-metallic elements. Carbon non-metal, nitrogen non-metal, oxygen non-metal, fluorine non-metal, neon non-metal. So this is the second period. So hydrogen and helium, the first period non-metal. Right? First period only hydrogen and helium. Second period carbon to neon. Boron is a metalloid. Third period, if you get, what are the non-metals? Phosphorus, sulfur, chlorine, argon. Now you can see what happened. Second period has the then if you go to the next one, then it's like you get only selenium and bromine. That means it decreases. So answer will be second period. Second period there are 5 non-metals. That is the period which contain highest number of non-metallic elements. So therefore A-level paper you can get 1 or 2 MCQs directly related with the periodic table also. Is that clear? So which period? Non-metallic element highest in which period? Second period. Answer is second. Question number 18, answer is second. Jinatmi correct, Chaniti correct. Yeah, okay. Then Ransiluni also correct. Then question number 19. 19th MCQ. What is the answer? Yes? What is the answer for the 19th MCQ? Liquids are very easy. This is also a question. Answer is liquid at room temperature. Answer is yes. I am waiting for your answer. Chaniti correct. Ransiluni correct. Chaniti, you wanted me to show the periodic table again? This one. Periodic table here. Non-metals you get carbon, nitrogen, oxygen, fluorine, neon, the second period non-metals. Now only I saw your message. Next period because silicon is a semiconductor, then next one you get only 4 non-metals, phosphorus to argon. Understood? Right. Then next one, what is the answer for the 19th? Answer is 19th answer is third. Very good. All of you are correct. Because mercury is liquid metal, bromine is liquid non-metal. 19, the answer is 3. Very good. Chanita correct, Ransil correct, Dinatmia also correct, Seshan also correct. Right. Then 20th also tell me, then we'll stop from here. 20th one, can you tell me the last one, the answer? After that, the rest I'll discuss next day. 20th one, again look at the periodic table. Number of gaseous elements at room temperature. How many elements exist as gases at room temperature here? Look at the periodic table and tell me the answer. How many gaseous ones? I'll highlight if you want. Okay, group 1, what is the gas? Hydrogen 1. Then again you get gases in group 5, nitrogen gas. Right, nitrogen gas. Hydrogen gas, nitrogen gas. Group 6, hydrogen gas. Then you get nitrogen gas. Then you get oxygen gas, fluorine gas, chlorine gas, helium gas, neon gas, argon gas, krypton gas, xenon gas, radon gas. This one we don't need, 118 one. Actually, A-level they don't give this row in the exam, so then you can this row means like this one from here to here they don't give actually, that we don't need to consider. But how many elements are there? 11 gases, right? 11 gases. 20th one, count how many? 11 gases. 11 gases. Correct. Answer is? What is the answer now? 11 gases means 20th you get the answer 4th. Answer is 4th. Answer is 4th. Very good. So here the answer is 4th. 11 gases are there. But it depends on the situation in the exam. Be careful, if they give everything, then this 118 now actually they don't this is the IUPAC periodic table, the latest one, but ALL periodic table they don't give that. Yeah, okay, don't worry. Radon until radon. Right, then it's almost 6:30 now, 6:35 almost. So shall we stop for today and we'll continue from 21 onwards. Next week I'll post one more paper. So this is remaining questions of this paper. Please try to do from there. How many MCQs are there? There are 50. There are 50 MCQs. So 50 MCQs we have done. We have finished today revision number 3 RG4. Sorry, RG4, RG5 also we have done half. The remaining questions I'll discuss next day, and I'll post one more paper next week, right? So next week the class is I will remind again, next week also the class this time, not at night, right? So not Thursday night. Some of the students also unable to come today. Those who I used to fix the class on Thursday, because earlier I gave the classes on Thursday, so they are requesting the recording, right? So any students of your, any of your friends, or if inform them the class time of Sunday, if they are free they can join this time. This is permanent until your A-level exam, online permanent class, right? No change of the time again, right? Okay, then I'll stop for today. Stay safe and God bless you all. Right, okay, Chaniti, I'll send the paper beforehand. Okay, sure, next time.